Save the date for .NET Conf 2019, happening September 23rd through the 25th. .NET Conf is a free 3-day virtual developer event co-organized by the .NET community and Microsoft. This year, .NET Core 3.0 launches at .NET Conf, so you don't want to miss out. Over the course of the 3 days, you will have a wide selection of live sessions that feature speakers from both the .NET product teams and the community. You'll have a chance to learn, ask questions live, and get inspired for your next software project. We'll have presentations on .NET Core and ASP.NET Core, C#, F#, Azure, Visual Studio, Xamarin Development, and much more. Head to www.dotnetconf.net. That's .NETconf.net to learn more and tune in.
In this episode of the On.NET Show, we're going to have Fabio coming on to talk to us about how we could leverage the new dependency injection feature inside of our Azure Functions v2 runtime. Check it out. Hey everybody, welcome to another episode of the On.NET Show. And with me today, I have my good friend Fabio. How are you doing, Fabio?
Doing well.
So you're going to come and talk to us a little bit about some of the updates that have been happening inside of Azure Functions. And particularly, we're going to talk about the dependency injection feature,
Right.
which I know a lot of people have been asking about. A lot of people have been waiting for it.
Highly requested feature, yes.
So, but before we dive into that, why don't we start with you telling us a little bit about who you are and what is it exactly that you do?
Sure. So I'm on the development team for Azure Functions.
Okay.
More specifically, the team responsible for some of the foundational components, the runtime, and some of the extensions and WebJobs SDK, the Power Functions.
Okay. Awesome, awesome. So tell me, I know a lot of people have been asking about DI, right?
Mm-hmm.
But why? Like, why is DI such a big deal for Azure Functions?
So I think one of the big reasons behind that is because the rest of the ecosystem jumped on dependency injection as
Sure.
it was very well supported in ASP.NET and
Mm-hmm.
.NET Core in general. So it is a pattern that enables decoupling from a lot of your services and the actual code consuming those services, making it easier for you to do things like testing and manage those dependencies. So because of that strong adoption that we've seen in ASP.NET Core and the rest of the ecosystem,
Sure.
A lot of people wanted to essentially apply the same set of skills, use the same features in Azure Functions. So we saw a high demand for that.
I know on the GitHub repo there have been a few issues where people have been a little bit very motivated in getting this feature in. Right?
That's one way to put it, yes.
Right. Okay. So talk to me a little bit about what was the engineering effort like? Like, what was it like behind the scenes to get this feature in? Because I know it wasn't just okay, we're just going to copy in this ASP.NET resolver and these DLLs and just turn it on, right?
Right. And to be honest, like most of the engineering effort really happened around the time we released 2.0.
Okay.
So it was really the work that happened in order to adopt a lot of the same abstractions that were being used by the rest of the ecosystem in the WebJobs SDK, which is, as I mentioned, the foundation for Azure Functions.
Got it.
So we made a lot of changes in the WebJobs SDK to make the WebJobs SDK DI friendly, which then enabled us to leverage those new capabilities within the Azure Functions host, which is essentially the runtime that orchestrates and manages all function executions.
Right.
So a lot of the effort was really enabling WebJobs SDK, pulling those changes through into the runtime, making sure that we were using a lot of those abstractions in a way that was consistent with the rest of the ecosystem. Okay. And exposing the right set of tooling and the APIs to enable that capability for functions specifically.
Right. Awesome. Okay. So why don't we dive into the demo and why don't you show us how exactly do we wire this stuff up?
Sure. Yeah. Absolutely. So I wanted to start with just a basic how-to sample, right?
Yeah.
So how do I actually take one of my services and I register that service and I actually express a dependency on that service from my function, so I can have that service instantiated and the lifetime managed for me.
Sure.
So the very first thing to keep in mind is that some of the APIs you need to use are actually in a NuGet package that we've exposed.
Okay.
So you do need to add a reference to Microsoft.azure.functions.extensions.
Okay.
These right now exposes all of the DI capabilities. We do expect to improve these with additional features as we go.
Got it.
And when you add a reference to that, you would have access to some types that are specifically built to enable the dependency injection capabilities within functions. very familiar with the model that you're using in ASP.NET, ASP.NET Core, if you're familiar with that approach.
Yeah, there's like an iService collection, and then you add my service or whatever.
You got it. We're using the same exact abstractions. So you see that the Microsoft extensions dependency injection, the namespace is referenced is used here. But we have this function startup, which is a type you derive from, defining your application startup for your function app. It's important to understand that when I define this, I'm defining for my entire app and not just one function within that app.
Sure.
And once I create this class, there will be a method giving me this builder option that will expose a few methods that are functions specifics, but you also have access to the services collection within the builder.
Right.
And this is, as you mentioned, just an instance of an iService collection. So all of the APIs, all of the extension methods that were built by the .NET Core team or third-party libraries using the same set of abstractions, it will just work and plug right into this process as well.
Right. That's awesome. So I know, for instance, I know the team has added support for like caching and DB context and HttpClientFactory and like a lot of these other things. So what's great to know is that I could just pull in these additional packages, I'm guessing.
That's right.
And that'll just light up because it's the same type.
Yep.
Right. And now I should be able to leverage those types of things inside of my function application.
That's correct. Yeah.
That's awesome.
A lot of the investments that were made, you get to leverage those investments here as well.
Gotcha. Okay. So now I've registered the service, right? Or you've registered the service. How exactly would I consume this inside of a function?
So what we see here is a sample registration, right, of this iGreeter service. I have a sample implementation of that. If I actually look at this interface, it's a pretty simple interface, a single method that creates a greeting, takes a name. I have an implementation of that here that just takes that name and returns some nice greeting. And here's the function that is actually using that service.
Okay.
So within my function, I have a constructor that expresses that dependency. So at this point, I'm just taking an instance of that interface. I'm persisting that in my class, in my function class, and in the function invocation, I'm actually using that greeter based on the name that I received from the HTTP request.
Now, one of the things I've noticed that's already different here is that, well, we're not using static classes and we're not using static methods anymore.
That's a good observation.
So
yes.
was that one of the updates that needed to happen for us to enable this DI feature?
Yeah. So that's one of the things that landed actually a little before we announced all of the DI capabilities. One of the things that people following the progress we were making on GitHub, one of the things they noticed is that as we were working on some of the features that were required to enable this capability, we were lighting them up. We weren't waiting to just release it all at once.
Sure.
So
there were incremental updates that kind of happened.
There were, and instance classes, like instance functions, was one of the things that we enabled early on during the process. So yeah, that's a good observation that you don't have to have a static method anymore. An instance of this class will be created for every single invocation with a service passed into that class.
Gotcha. Okay.
So if we were to actually see how this works here, we'll be able to let's set a couple of breakpoints and quickly run through these.
And so I'm going to assume that this is going to run the same way like we used to, right? Like, so it's going to boot up the functions runtime, and then it's going to go ahead and discover our functions because we have that function attribute on it. And then, I'm assuming we're going to see some URL at the bottom inside of those logs in a few seconds that'll let us know this is the endpoint that I can call.
You got it. Yeah, same exact process, same CLI, same.
Everything's the same. Like, so even though we've changed what the types are, even though they're not static anymore, like the programming model essentially is pretty much the same.
Exactly the same. Yes, that was preserved. Yeah. So you see, I have this URL for my function, my test function here, listening a sample function. I already have this HTTP request set up here, passing the name.
Okay.
Right. So I have a query string parameter that's being passed in. What we've noticed here is that when we invoke this function, we are given an instance of that greeter type. If we inspect that, we'll see that it's an instance of a sample greeter. So that's the implementation that we were just looking at a second ago. My function will be invoked. And since I do have the name set up here that I passed in as a query string parameter, what we should see in the response, if I switch back to Postman here, is that we have the exact same greeting that we had defined in the implementation of the aggregator.
Awesome. So that looks pretty easy to set up. I mean, again, all we're really doing from our previous functions, if we're talking about migrating over, is really just removing static, right?
Essentially.
And then now to enable the actual DI features, we have to create an implementation of that interface and then configure those services in there.
Correct.
Right. So there's really not a lot of moving pieces here to enhance like an already existing functions application if I wanted to add DI to it.
And for a lot of scenarios, these new capabilities actually enable you to significantly simplify your function.
Right.
So there were a lot of scenarios where it was your responsibility to manage the lifetime of some of the objects that you were consuming. HTTP client is a good example of that.
Yeah.
Where you had to have a static cache in the HTTP client and managing the lifetime. So it was all up to you to decide when you wanted to dispose of that client or when you wanted to reuse it.
Right.
For a lot of those scenarios, using this pattern and using the new capabilities significantly simplifies the code that you have for your function.
Right. And so kind of like what you said, we could pull in some of those packages that were introduced by the ASP.NET team. Since it's the same interface, we should be able to light up those same features.
That's right.
And so I know they have a feature called HttpClientFactory. Would that work in here as well?
Absolutely. Yeah.
Awesome.
Actually have a demo of that we can look at.
Sure.
Just leveraging some of the capabilities they've enabled. And the nice thing, as you mentioned, is that it's the same exact package, right? So we didn't build anything special to make use of HttpClientFactory in functions.
Right.
Everything is exactly the same set of APIs. So let me switch here to this project and set that as my startup as well. And we'll take a look at the startup class for this function app.
Sure.
Right. So what I have here is actually a couple different examples of the HttpClientFactory usage. If you're familiar with HttpClientFactory, this is the same exact API you would call when using this same feature in ASP.NET Core.
Yep.
Right. So this is the basic client factory usage where I add an HTTP client. And we also have an example here using a named HTTP client where I have the base address and some default headers set up here. I also have some transient error handling using Poly.
Oh, nice.
So showing how the same set of capabilities, you can leverage all of that within functions.
Right.
If we look at the actual function, what we see here is the pattern for the simple client. I'm just taking a dependency on the HTTP client factory.
Right.
When my function is invoked, I create a client, and then I use that client to issue a request. In this particular sample, I'm very simply just returning whatever status code that I get back from the downstream resource that I'm calling.
Yeah.
So quickly run through that as well, so we can see that in action. And most likely, what we're going to see here is just a 200 coming back from the execution of that request against GitHub in this particular case. So we see all the logs with the invocation details.
You know what makes me feel really good about this as I'm looking at your code is that I don't see you disposing HTTP client.
Yep.
And every time I'd go on GitHub or I'd look at somebody's code and I see them wrapping HTTP client in a using statement, I'm like, my heart dies a little bit. I'm like, oh no, don't do that.
And for functions customers, this was super impactful, right? Because when you're running in the consumption environment, there are some limitations. There are some limits that are imposed on you. Sure. So because of HTTP client misuse, we would see customers often run into socket exhaustion on the server, where this manages the lifetime of those objects for you. You don't have to worry about that as much.
Right, that's awesome.
So the other example that I have here is actually using named clients. The pattern for using typed clients, which is something else that the HttpClientFactory supports, is very similar to this, essentially the same. If you look, the nice thing about a lot of the features that we're building here is that the amount of documentation that we had to write about stuff like that is very small. Right. Because essentially what we're doing here is, here's the HttpClientFactory documentation. That's an investment that was already made by the team when they built the feature, the capability. So we get to leverage the same documentation, and that experience is consistent.
Right. It's also good to see that we're using our own products too.
Absolutely.
Right? Like, so we could leverage the work of other teams and just build better features together.
Yeah, absolutely. And we get to benefit from those investments moving forward as well. So anything new that we see leveraging the same set of abstractions and the same APIs, we'll just be able to adopt as well, which is great. But the pattern here for the named client, we are essentially doing the same thing in the constructor where we define the dependency on the HttpClientFactory. But within the function, here I'm looking for a specific client.
Right.
So I'm looking for the GitHub API client that I've set up, I've configured in my startup, and I'm just getting all of the pull requests for the Azure Functions host. So if we were to look at what that looks like here, for the named client, if I call the same function, and I'll put a breakpoint here so we can see that that function is actually being invoked. So we're walking through this. We got the appropriate client with all the configuration, the default headers. We got a response back from GitHub in this case, and essentially what we're doing is just passing the payload back as a result of the function. And we see the response from the GitHub API with all the pull requests we currently have open against the host.
Nice. Now, I know another thing that we do a lot, particularly in functions, is, before, whenever I wrote my function, I'd take a dependency on ILogger or something like that, and that's how I'd log information to App Insights or whatever the case is. So do we have support for that in here as well? Is that a dependency that we could just pull in now from the DI context?
Yeah, from the services, you would take a dependency on an ILogger T, the generic interface, and all of the logging providers that are set up for you out of the box with functions. So if you were to actually provide the App Insights key, which is something that we walk you through that process when creating the function app.
Right.
The logger provider that is already set up in the pipeline, when you take that ILogger, anything that you log to that ILogger will be pushed into the logging pipeline, to App Insights.
Awesome.
Something else, since we are in the talking about loggers, something else that you do have the ability to do is register additional logging providers. Right, so what I wanted to do, we talked a little bit about the ability that we have now to leverage the investments that all the teams have made into features that plug right into the dependency injection APIs. But I also wanted to highlight something using a third-party library, so something coming from a team, from a group of folks outside of Microsoft. Right, so the example that I have here is actually setting up a logger provider using Serilog. They have a bunch of different syncs. They have a bunch of different logging options. For this particular example, I'm just logging things to a file, right? So I'm, again, just setting up a startup class in the configuration. I'm just adding the logging, same set of APIs, and then I add Serilog to the logging pipeline. What we'll see here is that in this particular case, my function, it's as simple as it gets, right? It doesn't even return anything. It's just a function that will log an error. And we have some log entry. I'll open up here the folder that we have set up, so we don't have anything in that folder right now. So if I was to actually run and execute that function, it would see what you would expect, right? So that logger provider is now injected into the logging pipeline. Anything that my functions log, anything that the host log, will be pushed into the same logging pipeline. So if I was to, let's pick up the URL from here that we get back from the CLI. And let's make that request.
So you're going to run this in Postman. It's going to execute your function. And I'm assuming now, like when you go back to that folder, there should be a log file in that folder.
I hope that is.
I hope there's a log file in the folder.
I hope that is one.
Because you set up with Serilog in the configuration.
We do see the execution logs. We see the standard logs that we get back from functions. So that's part of the standard logging pipeline that we have set up. But if we switch that folder, we should see now.
There's a file.
There is a file.
Awesome.
Right? So that's the file that was emitted by Serilog, by one of their syncs. If we inspect that file, we'll see not just your function logs, but also logs at the host level, everything that's happening in the invocation pipeline. With these, you have the ability to register log filters and a bunch of the things that you would expect to manage, a lot of the things that you would expect to manage with the logging APIs.
Nice. So we talked a little bit about, so we see how we could set up HttpClientFactory and the logging. Do we have any other services that are just registered for us by default that we could pull in?
We do. So ILogger of T was one of the services that we talked about.
Yeah.
So the service, you can take a dependency on that. What I would like the way I'd like to answer your question is by referencing the documentation that we have
Sure.
for Azure Functions dependency injection.
That's why we write the docs, right? So people can read it.
Right. And the reason why I want to do that is because we are exposing, if you go to the documentation, there is a section about the function app provided services. It's a very small set right now, and that's intentional.
Okay.
Over time, we do expect that we'll grow the number of services that we provide out of the box.
Yep.
The built-in services that you can use.
Sure.
That's why referencing the documentation, going to the documentation when you need to use services is the best way to find out what's available to you at that point in time.
Great, that's awesome. And I think if people want to as well, like they're always able to submit a GitHub issue or make a feature request or something like that on the repo.
No, absolutely.
In case
And
there's a
if we
particular
see-
thing they
yeah,
want.
If we see demand, if we see that there's a need for a particular service to be exposed, that's how we will be adding them to the runtime.
Cool, awesome. This was great, man. So if I want to check out these samples that you've written for us, like where can I go? Are these on your repo somewhere?
They are, and I'll leave the link with you so we can share the link, so you can have access to the code. You can clone these and take a look at all of the samples. One of the things we didn't talk about too much was all of the scoping options for services as well.
Right.
So this is something that we support, very similar to what you would expect to see based on if you have any knowledge of how scoping works in ASP.NET Core.
Sure.
So you do have the ability to register transient services, scoped services, which will be the lifetime will actually match the function invocation lifetime.
Yeah.
As well as singleton services. And we have a sample that shows all of that here.
So pretty much all of the scoping options that we have in ASP.NET, like you support them right here.
That's correct. Yeah.
Awesome. And you didn't have to do anything special, right? Like you said, like we could just...
Yeah,
from a developer
one key
perspective,
difference,
like we could just...
from a developer perspective, the experience is the same.
Yeah.
Yeah.
Awesome. This is great, man. Well, hey, thank you so much for coming on. I
Thank
really
you.
appreciate
Thank you for having me.
Now I'm gonna make sure we add the links and everything inside of the show notes so everybody could go and check that out.
Sounds great.
And thank you all for watching. And this has been another episode of the On.NET Show. We had Fabio telling us about how we could add dependency injection to our Azure Functions applications.
Thank you.